Greetings, welcome. Today we're going to learn and take some pretty short notes on how to identify organisms. And there are some unique looking fungi right there on the screen, and those are called fruticose fungi, and you might see them from time to time growing on an old fence post after it's rained. The main idea today, it's short and simple, is something called the dichotomous key, and it is a tool used for identifying organisms. So it's something we use when we don't know what we have, but we're trying to figure it out. Now, it really can come in two different shapes or styles, so we'll look at a couple of examples, and then I'll give you some homework to work on that, so you can get some practice using a dichotomous key. How this works, dichotomous, you see the word di in there, that means two. A dichotomous key is usually a list of pairs of traits you can observe about organisms. And as you work through the different pairs, it's always one or the other, and you keep picking those pairs, and eventually you reach a point where it tells you what the organism is. We call up the first example on the screen. This is a really simple dichotomous key for 4 animals: a duck, a hen, a lizard, and a snake. Let's imagine we're idiots and we don't know what a duck, a hen, a lizard, or a snake is. So if I'm holding one in my hand, I can read through this dichotomous key. And you start on the far left, and it says feathers, yes or no. So that's your pair of statements. Yes, it has feathers, or no, it doesn't. So let's imagine I have this long, skinny thing with no feathers and no legs. So I'd go feathers, no. Then I go to the next pair of statements. Legs, no. So what do I have? I have a snake in my hands. Awesome. Or terrible, depends on your opinion. Let's say I pick up another animal and I get feathers. Yes, it has feathers. And then I say, can it swim? So I throw it in the water and it drowns. That means I have a hen. Okay? So the dichotomous key helps me identify what the organisms are. Here's another dichotomous key that just shows you how to put things in the right kingdom. So the first pair of statements is it prokaryotic or eukaryotic? Does it not have a nucleus, or does it have a nucleus? And if it doesn't, then I am in the kingdom Onera. I'm already done. If it doesn't, I could continue on through the rest of that dichotomous key: unicellular, multicellular, heterotrophs, autotrophs, and so on. And if it absorbed the nutrients, it'd be kingdom fungi. But if it used a mouth to get them, it'd be the kingdom Animalia. Here's the other way they can show up. There's really 2 ways that a dichotomous key can show up. This is, instead of kind of the picture where you kind of go through the chart, this will just have pairs of statements and you follow the numbers until you reach an answer. So we're going to take this red piece of candy and ignore the name on there and pretend we don't know what it is. And we're going to work through the statement. So I'm going to start over here by number 1, and it says candy is chewy or candy is hard. One of those 2 applies. And if we look at this thing, we say, oh, the candy is hard. So that tells us to go to number 7. So we drop down to number 7, and it says candy is spherical, like ball-shaped, or candy is not spherical. It's not, so I'm going to go down to number 9. Number 9 says the wrapper is transparent. No, I can't see through that. So that's 9B, the wrapper tells the flavor. And it does say cherry style, I think, right there. So it does tell the flavor. And now I have my name, Joyous Rancheria, which is really a Latin, joke Latin word of Jolly Rancher. And if you look at some of the other ones on here, they're actually pretty funny. Like number 2B, Ursa is the scientific name for bear. So Ursa gummius is a gummy bear. And Saltus taffenia is saltwater taffy. Tutus rollus, number 5A, that's a Tootsie Roll. And you can look at some of the others if you want and try to figure them out, but they're actually kind of funny. Now, deep thoughts. I remember how my great uncle Jerry would sit on the porch and whittle all day long. Once he whittled me a toy boat out of a larger toy boat I had. It was almost as good as the first one, except now I had bumpy whittle marks all over it, and no paint because he had whittled off the paint. Alright, we're going to skip that for now. And last, just a little bit of environmental awareness. Researchers are constantly looking for new organisms that haven't been classified yet. And there's a purpose to this. For example, scientists recently discovered an unknown form of fungi, which will allow them to classify the form that produces a drug called cyclosporin, which people take when they have a liver transplant or a kidney transplant. So if you can find a fungus or a bacteria or a protist, and it has something helpful in it, you might try to look for other ones that are similar in that family of classification, which might have other helpful drugs. So classification has a real practical value. And one thing we also notice as we do classification is how we're losing a lot of species, and a lot of that is human caused. Okay, there's about 25,000 endangered species right now. Some of that is just due to they were at their end of their species lifespan, but others are happening because humans are taking up so much space and using so many resources that we're wiping out a lot of these species. And right now the rate is at an all-time high. So that's bad. All right, so Mrs. Nelson is going to pass out the homework. There's two. One is to use a dichotomous key to figure out who all these wacky people are. Once you finish that one, then you're going to make your own dichotomous key for 10 teachers at Calvin Christian, and their pictures are up in a Google slide on the Moodle page. So those are the teachers to use to create your own dichotomous key. So have fun and have a great day.